This video is going to cover part 1 of Pre-Calc Notes 2.7. The topic in this section is solving polynomial and rational inequalities as opposed to equations. So what I'm going to do to be able to solve a inequality such as this one is, since it's a degree 2 polynomial, I want my problem to be equal to 0. So I'm going to move the 3 over. And then I'm going to have to factor this. So I'm going to ask myself what multiplies to be negative 3, adds to be 2, so negative 3 from the last term, 2 from the middle, and I know that it's got to be a 3 and a 1, where the 1 is the negative to make it add to be a positive 2. So this would break down to be x plus 3 and x minus 1 is greater than or equal to 0. So what I'm going to do is I'm just going to set both of these individually equal to 0, and I'm going to disregard my inequality sign. So I'm going to change it to an equal sign. And that would give me an x value equal to 1 and negative 3. And now what I have to do, because we're saying that this is greater than or equal to 0, is I have to figure out all of the values that make this work. It's not just going to be these two, because these two are what makes my equation exactly equal to 0. And this is where the number line is going to come into play. So let's put our two numbers on the number line. The negative number would go to the left of the positive number. And in the past, when we did this, we graphed these and we put either open or closed circles, depending on what our inequality was. Our inequality sign this time is equal to, so we used closed circles. When it was not equal to, we used open circles. So I'm just going to put the open and closed circles up here. That's something that you're used to seeing, but since we're going to want to give our answers in what's called interval notation, we don't want to use open and closed circles. We want to use either brackets or parentheses. Since our problem can be equal to 3, we want to put a set of brackets on our number line. The problem is I don't know whether my bracket should go this way or whether it should go this way. So I kind of have to wait to figure that out until after I know where I'm supposed to shade on my number line. So let's talk about that. What's going to happen when you put these numbers onto the number line is it will divide your graph into 3 sections. So we'll call it zone 1, zone 2, and zone 3. You need to pick numbers that are in those zones to test to see whether they are true or false statements. So if I'm talking about zone 1, what is a number that I can pick that falls in this zone? Well, the easiest number to pick would be negative 4. So I'm going to set x equal to negative 4, plug it into my original equation, and see what I get. So negative 4 squared plus 2 times negative 4, is that greater than or equal to 3? 16 minus 8. Yeah, 8 is greater than or equal to negative 3. So that's true. So that means that all the numbers in that zone work, so I shade that zone. Okay, let's talk about zone 2 now. Zone 2, pick a number that's in zone 2. The easiest one to pick there would be 0. So we're going to use x equal to 0. So is 0 squared plus 2 times 0 greater than or equal to 3? Well, no. 0 is not greater than or equal to 3. That's false. That means I don't shade that zone. And then finally, we'll pick zone 3. Number we can use here, pick a number that's bigger than 1, so I'll just use 2. So we'll do 2 squared plus 2 times 2 and see if that's greater than or equal to 3. Well, 4 plus 4 is 8, so I get 8 is greater than or equal to 3. So that's true. So that means I'm going to shade that zone also. So I want to put arrowheads out on the end because I know that this will continue off in that pattern. And now I can put my brackets on. Since I'm not shading the middle, I've got to put my brackets on so that they face the zones at work. So I'd put a bracket here, and I'd put a bracket here. Now the brackets are going to be important that I put those on the number line because my number line is not really my answer. The answer is, it says, write it in interval notation. And the way we're used to writing this is we're used to writing it with x's. We would say, okay, this means that x has to be less than or equal to negative 3, and this means that x has to be greater than or equal to 1. But if I'm writing it in interval notation, I'm going to write it with brackets or with parentheses. So this is really saying any number that's less than negative 3 or equal to negative 3 works. And the way I'd write that in interval notation is I'd write from negative infinity, comma, 3, where it's equal to 3, but not equal to negative infinity, because you can never equal negative infinity. And the way I would write this, when x has to be greater than or equal to 1, let me erase some of this so that I have some room over here on my answer line here. I'm going to say or, not and, because it can't be both of these at the same time. It could be either a number in this zone or a number in this zone. So it could be equal to 1 or a number that goes all the way to infinity. Again, the bracket is going to symbolize that it can be equal to 1 and negative 3, and I'm saying infinity because infinity is way out here, and I'm saying over here negative infinity because that's negative infinity way over there. So this is the way I would write my answer in interval notation. This is the way I would write it as an inequality. And you're used to writing it as inequalities. I'd like you to write them as interval notation. So essentially you solve your problem. Most of the time you're going to solve it by trying to factor, so you usually want to make your problem be equal to 0, or in this case greater than or equal to 0. And then you put those numbers on the number line to divide it up into zones, and then you test numbers in each of those zones to see which numbers work, so you can figure out where to shade. Let's take a look at another example. This time my problem is already greater than 0, so I don't have to move anything over. And my factoring technique now is going to be to pull out the greatest common factor. I know in this problem that should be a 4x squared. So let's take a 4x squared out. That's going to leave me with an x minus 3. So if I factor this out, and now my problem is greater than 0, so I can actually set both parts of this problem, the 4x squared, I can set that greater than 0. Actually, I want to set that equal to 0. And I want to set the x minus 3 equal to 0 also. So I'm going to end up getting, if I divide by 4 and take the square root, I end up getting 0. And if I add 3 here, I'm going to get x equals 3. So these are what we call our critical numbers. They're called our critical numbers because they're the numbers we're going to put on the number line. So if it asks you to find the critical numbers, it's just the numbers that you get when you end up factoring, or the polynomial that you have started with. Now I've got to pay attention to the fact that my problem is not equal to, so it cannot be equal to these values. So I'm going to have to put parentheses on here and not brackets. I'm just going to make a little note up here, use parentheses because it's not equal to. Okay, so now that I've got my numbers on here, that's going to divide our graph up into 3 test zones. So if I'm going to pick a value for test zone 1, I'm going to use negative 1. In test zone 2, let's use x equals 1, and in test zone 3, let's use x equals, let's say 4. You can use any number in there. Obviously, the smaller the number, the easier your algebra will be. So let's plug it into our original equation, so back up into this. So 4 times negative 1 cubed minus 12 times negative 1 squared, is that greater than 0? So this is going to give me a negative 4. This is going to give me a negative 12, so I get negative 16 is greater than 0. Well, that's not true. Negative 16 is not greater than 0, so this is false. So it means I don't shade that zone. Moving to the next one, I'm actually going to I'll do the work down here so I don't write it over that blank. We'll do 4 times 1 cubed minus 12 times 1 squared. Is that greater than 0? This is going to give me 4. This is going to give me 12. Negative 8 is not greater than 0, so that's also false. And then finally, using an x equal to 4, again I'll do that down here so I'm not writing on the answer blank. So this is going to be 4 times 4 cubed minus 12 times 4 squared. I want to know if that's going to be greater than 0. So this is going to give me 256 minus 192, and that gives me 64, and I know that 64 is greater than 0, so that's true. So I'm going to shade that region and draw my arrowhead here. So now, because of the fact that that 3 was not equal to, it can't be equal to, then I put a parenthesis there. So in terms of writing my interval notation, remember I know that this is moving over to positive infinity, so I'm going to put parenthesis 3 comma positive infinity and then parenthesis. You always put a parenthesis next to your infinity and your negative infinity because you can never be equal to. The way we're used to seeing this, though, in inequality notation is we would say x has to be greater than 3. But again, we want to write our answers in interval notation, so it would look like this. Alright, so for our next example, the polynomial that we have is negative 2x squared plus 6x plus 15. And you could take the time to try to factor it, but I'm already telling you that it's not factorable. So if we can't factor it, then we have to use the quadratic formula. So I'll list that up here in case you forgot. Negative b plus or minus b squared minus 4ac over 2 times a. So looking at my problem, since it's less than or equal to 0, I know that my a is negative 2, my b is 6, and my c is 15. So negative 6 plus or minus the square root of 6 squared minus 4 times negative 2 times 15. All of that then would be divided by 2 times negative 2. So I like to always simplify what's outside and what's underneath first, then figure out what's underneath my square root sign, so 36, and then this would be plus whatever that is going to give me, let's see, 156. So if I'm thinking about simplifying 156, then I'm going to come up with a perfect square that goes inside of 156, and I know that it's 4. 4 times 39, so I know that this really is going to be, since it's the square root of 4 times the square root of 39, it'd be 2 square roots of 39 over negative 4. So that's my exact value answer. This is going to be a little bit difficult for me to put on the graph. Actually, I take that back. Before I circle that, I should have reduced this. I can actually divide all of these out by a 2. So if I end up doing that, I'm going to end up with having a negative 3 plus or minus the square root of 39 over negative 2. That's the actual exact value answer. But to put this on my number line is going to be kind of difficult, so I want to take the time to change them to decimals, so have an idea of which numbers I should pick on my number line. So if I type this into the calculator, as a decimal it's going to be about negative 1.6 and 4.6. So I'm going to put this on the number line by saying that this one was negative 3 plus the square root of 39 over negative 2, and that was really the same as negative 1.6, and this one was negative 3 minus the square root of 39 over negative 2, and that was 4.6. Okay, so now that I've done that, now that will divide my test zone up into, or my graph into 3 test zones, 1, 2, and 3. And then we can discuss which x values we're going to use. So I'm going to use x equals negative 2 for the first zone. I'll use 0 in the middle, and I'll use 5 on the outside. And I'm going to run out of time on this video, so I'll pick up on the next video with plugging these in to figure out where we shade.